Hello everyone, how are you? So, my dear friends, in the last session, we have discussed about the basic concept of the stop and wait protocol, where I have derived the formula for utilization of network, or you can say the channel. Okay. So, in case of a stop and wait protocol, what is the utilization of channel? That we have already calculated, TF upon TF plus 2 TP. So this is the utilization if the T of processing is tending to 0 and T of ACK is also tending to 0. So if these two parameters are negligible, then only we can say the utilization of the channel will be this. Okay, and we also know that the utilization of the channel would be minimum 0 and maximum 1, that is the 100%. Okay, so here first of all we have calculated what utilization of channel, and the second parameter that we need to calculate was the what throughput of the channel. So my dear friends, throughput of channel, throughput, or you can say effective bandwidth, effective data rate, or you can say bandwidth, because the data rate is sometimes also called as bandwidth. So how we basically represent the bandwidth is represented by the capital R. So the throughput will be represented by, that is the effective throughput will be represented by this. So R means data rate, E means effective. So ultimately these things will represent the effective data rate, or you can say effective bandwidth. Okay, now you are able to understand the notation that I have used over here. Now let's see the throughput. How we can define the throughput? Generally, how we basically define the throughput, already you have heard this term in operating system. Already we have heard this particular term. So what is the meaning of throughput? Something happening per unit time. That something could be anything. You can take anything as a reference. Like in an operating system, what we say, number of process in a something, we basically consider number of process executed per unit time. Yes or no? Per unit time. That is called the throughput in operating system. And here in place of something, we will consider the number of bits. So basically the sender transmit the frames, and frame is nothing but containing the bits, sequence of bits. So here how we can define the throughput, the total number of bits transmitted per unit time. So here the throughput is defined as total number of bits transmitted successfully, you can write transmitted successfully per unit time, transmitted successfully per unit time. So my dear friends, what is in case of stop and wait protocol, because we are trying to calculate this throughput in case of stop and wait protocol, okay. So in case of stop and wait protocol, we are trying to calculate the throughput, or you can say the effective data rate, and here it is basically defined as the total number of bits transmitted per unit time. So to transmit single frame successfully, what is the total time taken by the sender? That is the TF plus 2TP. If we are ignoring these two parameters, and out of this total time, how many bits we are transmitting, whatever the size of frame, and what is the size of frame that we have considered, L bits, yes or no? So simply you can write it in this way, that is the L number of bits divided by total time means TF plus 2TP. So here we are assuming that T of processing is tending to 0 and T of ACK is also tending to 0. Okay, so this is in bits and this is will be given in second. Yes or no? So L is what? L is the number of bit contained by a frame. L is the size of frame, you can say. So L number of bits will be transmitted by a sender and to confirm the successful delivery of this number of bits, what will be the total time required? This. So ultimately this one will become L upon TF plus 2 TP into here you can write BPS. Here this one is given in the form of bits and this one is second. So ultimately you can write bit per second. So this one BPS. Now we are trying to modify this. See, once you will divide L by R and just multiply it by R, the things will remain same. Divided by TF plus 2 TP. Now my dear friends, what is the L by R is? L by R is nothing but the transmission time of a single frame. So here you can write this is the TF upon TF plus 2 TP into R. And what is this? So this is nothing but the channel utilization. Yes or no? So ultimately you can write the same thing in this way, the channel utilization into R. So finally we have derived the effective throughput in this way. Effective throughput or the data rate in this way. Yes or no? Got it? So the effective data rate is equivalent to the channel utilization multiplied with the bandwidth. So here please try to understand, this R is representing actual bandwidth and this R of E basically represents effective bandwidth. Now please try to understand why we are saying effective bandwidth, because it is calculated in the effect of channel utilization. Why we are saying effective bandwidth, please try to understand. This is calculated in the effect of channel utilization. My dear friends, if the channel utilization is 100%, in that situation the effective bandwidth will be equivalent to the actual bandwidth. Or if channel utilization will be less than 100%, then definitely the effective bandwidth will be calculated accordingly. So we are saying it effective. Okay, it is called effective because it is calculated in the effect of channel utilization, got it, in channel utilization. So if the channel utilization is 100%, then only the effective bandwidth will be equivalent to the actual bandwidth. Okay, so ultimately we can write the effective bandwidth. Okay, so you can say this as a throughput. Okay, effective bandwidth, or you can say the throughput. This is equivalent to L upon TF plus 2 TP, or you can say this is equivalent to eta into R. And these derivations we have calculated in case of stop and wait protocol. Okay, so according to the data given inside the questions, either you can use this formula or you can use this formula. Okay, so this formula we have written assuming this formula we have written assuming that the T of processing is tending to 0 and the T of ACK is also tending to 0. Okay, so to understand these two formula, that is the utilization of the channel and the effective bandwidth, or you can say the throughput, please try to solve some of the GATE previous year numericals. Okay, so let's start the GATE previous year numerical. Okay, so just see over here, okay. So just come and look upon this, okay. Sorry, we are talking about, okay, see, we are talking about, okay, just see over here, okay, chapter 2, okay, chapter 2, data link layer. Since we are dealing with the data link layer, so we will look upon the previous year problem of the data link layer, okay, of the data link layer. So just see, uh, save data possible, go back and we will try to solve almost 2 to 3 problems based on this concept, okay. Based on this concept we will try to solve 2 to 3 problems. So just see, I'm trying to identify, okay. So this is the first problem, you can see over here, okay. Based on the sliding window na, we need a stop and wait protocol, okay. So this is the first problem, just look upon over here, this is the question number 20, and this has been asked in GATE 2005. So my dear friends, read the question properly and tell me the right answer. Everyone, just read the question properly and tell me the right answer of this question, okay. Take your time, not a problem at all. Just take your time and give me the right answer of this question. Already we have learned all the related concept for this problem. Already we have learned. So take your time and just give me the right answer of this question. Okay. So see, a channel has a bit rate of 4 kbps. Okay. Bit rate of 4 kbps. So whenever after reading the question or parallelly on reading the question, try to collect the informations given inside the question. Means in case of computer network problem, collection of data from the questions is very important. If you are able to collect the data given inside the questions, then you can easily solve any kind of numericals. What I am trying to say, please try to understand. See, it is given a channel has a bit rate. Bit rate means bandwidth, that is R. Bit rate, or you can say data rate, both are the same thing, or you can say the bandwidth, okay. So a channel has a bit rate of 4 kbps, means this is nothing but R is equal to 4 kbps. It is given, and one-way propagation delay. So what does it mean? See, suppose this is the sender and this one is the receiver. So between sender and receiver, the data will be transmitted in this way. So this is called one-way propagation delay. But between sender and receiver, okay, going the data from one side to the another side and coming the acknowledgement. So this is called two-way propagation delay. So this one is called one-way propagation, and this is called going the frame and coming the acknowledgement. So this is called two-way propagation delay. Okay. So whenever one way is given, it simply means TP is given, and whenever two way is given, it simply means 2 TP is given. Are you getting my point or not? So one way propagation delay is given as 20 milliseconds. So this is nothing but a TP is equal to 20 millisecond. Yes or no? Now read ahead. The channel uses stop and wait protocol. The transmission time of the acknowledgement frame is negligible. See, the transmission time of the acknowledgement frame is negligible. What does it mean? So here, according to this statement, T of ACK is given as 0. Now, to get the channel efficiency. So see, either you can use the term channel utilization or you can use the term channel efficiency. So meaning of both the terms are same. Okay, so see, either we are using a term channel utilization, or in some standard book it is given as channel efficiency. So meaning of both the terms are same, that is nothing but eta. So here in this question it is given to get the channel efficiency of at least 50%. At least 50% the minimum frame size should be. So to get the channel efficiency of at least 50%, you need to find out the frame size. What is the frame size? That is indicated by L. The size of the frame will be always indicated by L. Okay, so in the given question the information is given like this: R is equal to given as 4 kbps. Okay, and one way propagation delay, that is the TP, is given as 20 millisecond. Yes or no? So R is given, TP is given, and channel utilization is given. You need to only identify the value of L. So according to the stop and wait protocol, what is the channel utilization? The channel utilization is TF upon TF plus 2TP. When if T of processing is tending to 0 and T of ACK is also tending to 0. So see, please try to understand, inside the question this information is already given. Inside the question this information is already given, that the transmission time of the acknowledgement frame is negligible. They haven't said anything about the processing time. So see, if inside the question they are not saying anything about any time, that is the processing time, then we have to consider that as a 0. Are you getting my point? Is that clear? If nothing is said about the processing time, then we will assume it as a 0. Is that clear? So if the processing time and the acknowledgement transmission times are 0, then the channel utilization in case of a stop and wait protocol will be written like this. Yes or no? Will be written like this, and we already know that TF is equal to L upon R. Yes or no? We already know the transmission time of the frame is nothing but L upon R. So just try to write over here. Channel utilization is given. This is given as 50%. Okay, is equal to, what is the meaning of TF? This is the L upon R, and again TF. This is nothing but L upon R and plus 2TP. 2TP means 2 into TP. The value of TP is 20 millisecond. Okay, millisecond. Is that clear? Now just see over here. 50%. What does it mean? 1 upon 2 is equal to, see, if you are cancelling these two R, means the R will be multiplied over here. Yes or no? If we are cancelling this 2, then R will be multiplied over here. So finally what you can write? You can write L upon, this is the L plus 2 into 20 into, what is the R given? The value of R is given as 4 kbps. That is the 4K. What is the meaning of K? See, already I have told you 1K is basically equivalent to 10 to the power 3. So whenever K is given, it means 10 to the power 3. Okay, 10 to the power 3. So KBPS means bit per second. What does it mean? This is nothing but the bits per second. BPS means bits per second. So just write over here. So this is given in the form of bits per second, and this is the millisecond. So convert this millisecond into a second. So what you can write? So this is the 10 to the power minus 3 second, and these things is given in the form of BPS. So here you can write bits per second. Yes or no? So definitely this second will be cancelled out. This is given in the form of bits per second, so you can simply write bit per second. Okay, and this was given in millisecond. So once you will convert the milli into a second, you can write 10 to the power minus 3 second. So this second will be cancelled out, and whatever you are calculating will be in the form of bits. Now you can see over here 10 to the power minus 3, and the 3 will be cancelled out. Now do the cross multiplication. So once this L will be multiplied with this, so 2L is equal to L plus 2 into 20, 40 into 4, that is the 160, and this should be in the form of what? Bits, in the form of bits. So finally once you will take this L on the left hand side, so this one will become L is equal to 160 bits, and this one will become your final answer. Is that clear? This one will become your final answer. Okay, now let's try to solve one more problems, okay, based on the same concept. Okay, then you will get some confidence. See, solving a GATE previous year numericals will give us the confidence. So always try to solve as much problem as possible related with your concept. Okay, so let's come to the another problem and try to solve it out. Okay, so this was the question number 20 from the GATE 2005. Okay, from the GATE 2005. Now just see over here, we are migrating like 44. Okay, so this question is related with, okay, see, okay, this one. Now this question is the question number 38, and this question has been asked, you can see over here, in the year of 2016, and the question is simply based on stop and wait protocol. So what I want, you just read the question properly, try to collect the information given inside the question, and then step by step just approach the solution. Step by step just approach the solution. Is that clear? So collection of information from the given question is very important, because ultimately you need to apply the formula only, and that formula I have already derived. You don't need to remember the formula. Whenever you will forget the formula, what you can do, you can derive it, because I have taught you how to derive the formula also. Okay, so read the question properly, find out the data given inside the question, and just apply the formula to get the answer. Okay, so take your time, not a problem at all. Everyone, just take your time. Chalo bhai. Sender uses the stop and wait ARQ protocol for the reliable transmission of frames. Okay, now frames are of size 1000 bytes. Okay, so see, what is the size of frame given? The size of frame is given as 1000 what? Bytes. 1000 bytes. Okay, now and the transmission rate at the sender is 80 kbps. See, the sender, this is the sender and this is the receiver, and the transmission rate at the sender side is given as 80 kbps. Okay, and the size of acknowledgement frame. Okay, so here value of L is given as 1000 bytes. Okay, and the size of acknowledgement frame is given as 100 bytes. So acknowledgement will acknowledgement will be transmitted by the receiver. So who is responsible to transmit the acknowledgement frame? Receiver, and the size of acknowledgement frame is given as 100 bytes. Okay, 100 bytes, and the transmission rate, you can see over here, transmission rate at the receiver is this. So here the receiver transmission rate is given as 8 kbps. Okay, now the one-way propagation delay means TP, that is given as 100 millisecond. One-way propagation delay is given as 100 millisecond, assuming no frame is lost. Okay, the sender throughput is, you need to find out the sender throughput, and your answer should be in the form of what? Byte per second. So the sender throughput that you have to answer should be in byte per second, and this is the numeric type question. You have to put the numeric answer over here. Okay. So collecting this information, see, looking upon the sender bandwidth and the frame size, what we can calculate? We can calculate the TF, and TF is nothing but L upon R. So what is the value of L given? L is 1000 bytes. 1000 bytes, convert the byte into bits. So you can write 8 bits divided by R, that is the R1, 80 kbps. So this one is 80 into K. What is the meaning of K? 10 to the power 3. BPS means bits per second. So definitely bits will be cancelled out. Okay, from this 0 will be cancelled out, 8 will be cancelled with this. Okay, so this is nothing but 100 into 10 to the power minus 3 second. So simply you can write 100 millisecond. Yes or no? The TF will become 100 millisecond, and TP is already given inside the question, that is the 100 millisecond. Now look upon this. Acknowledgement size is given and the transmission rate of the receiver is given. So from these two parameters, what we can calculate? We can calculate the transmission time of the acknowledgement. So that is nothing but L of ACK divided by R2, that is the receiver transmission rate. L of ACK is given as 100 byte. Convert the byte into bits. So this one will become 8 bits divided by bandwidth, that is the 8K. K means 10 to the power 3 bits per second. So definitely this bits will be cancelled out, and here 8 will be cancelled out. Now you can write this one is 100 into 10 to the power minus 3 second. So finally you can write 100 millisecond. So my dear friends, what ultimately we are collecting, okay, the TF is 100 millisecond, T of ACK is 100 millisecond, and TP is also 100 millisecond. So ultimately we have calculated that the TF is 100 millisecond, okay, TP already given 100 millisecond, and T of ACK we have calculated as 100 millisecond. Okay, and we need to find out what? Sender throughput. So what is the sender throughput? Total number of bits transmitted. So that is nothing but L divided by total time. Total time means TF plus 2TP and plus T of ACK. Here we can't ignore the transmission time of the acknowledgement because it is already given inside the question. So here only we are ignoring what? The processing time, because no informations about the processing time is given. Are you getting my point or not? So in place of total time we are considering this. Why? Because you have to consider the transmission time of the acknowledgement also. So L is the number of bits transmitted divided by total time. That will become sender throughput, or you can say effective bandwidth. Yes or no? So what is the sender frame size is given? That is nothing but 1000 what? Bytes. The sender frame size is given as 1000 bytes. Yes or no? So 1000 bytes divided by total time. So what is the TF? TF is 100 plus 2 into TP. TP is also 100 plus T of ACK 100, and this is coming out to be in millisecond. Yes or no? This is coming out to be in millisecond. So ultimately this one will become 1000 bytes divided by 100, 200, 100, 400. Convert the milli into second. So this is a 10 to the power minus second. Yes or no? Yes or no? So from this 0, this one will be cancelled, this 0, this one will be cancelled. So this one will become 10 into, take this on the upper side, 10 to the power 3 divided by 4, and this is coming out to be in what? Byte per second, and ultimately you need to give the answer in the form of byte per second. So the things you are calculating over here is coming out to be in byte per second. Yes or no? And you need to give the answer into the form of bytes per second. Got it? So this is the 10,000 divided by 4. So this one will become what? This one will become 2500 what? Byte per second. Capital B means byte per second. So ultimately you need to give the answer in the form of bytes per second. So this one will become your final answer. So in the numeric box, you can simply put the answer 2500. Got it? 2500. So this is another question from the GATE 2016 based on simply stop and wait protocol. So my dear friends, if you have a basic concept of the stop and wait protocol, you can attempt any kind of problems. You can just attempt any kind of problems. Okay, is that clear, everyone? So this is the concept of the stop and wait protocol and all the associated numericals. There are some more numericals also. I am giving you one of them. Because so that you can try to attempt those numericals. Okay, so you can just take the screenshot of the problem, not a problem at all. So once I will show you the question, you can take the screenshot. So this is the one of the another problem based on stop and wait protocol. You can just see over here. So this is the question based on stop and wait ARQ protocol, and this question has been asked in GATE 2017. What I want, you just take the screenshot of this problem. Okay, because the question is very simple. Here you have to assume all the parameters like acknowledgement transmission time, processing time. Okay, acknowledgement transmission time and processing time. Okay, so just look upon this and try to solve it out. You can easily find out the answer, not a problem at all. Okay, already I have told you, read the question properly and try to collect the information given inside the question. Because if you are able to collect the information, you can simply apply the formula and get the answer. Is that clear? So what you have to do, you just read this question properly, try to solve it out, and once you will get some answer, okay, you can share with me in my telegram. Okay, to make the session interactive, you can just share your solution in my telegram number, that is the 9264954515. so this is my telegram number. Once you are getting any answer, you can just share with me, so that we can have a discussion on this. If your answer is correct, then I will simply say it is correct. If I will find you are missing or you are lacking with some concept, definitely I will guide you. So just don't worry, everyone. Is that clear? Just don't worry. Keep learning and move ahead. What is our slogan? Keep learning and just move ahead. And if we are facing any problem, because without problem we cannot achieve something in our life. So life is always filled with the problem. So if you will learn how to face and how to tackle all these problems, then you can move ahead with the experience, and that experience will help you out to achieve your target. So try to solve it out, and if you are not getting the answer, or you are somewhere lacking with the concept, definitely I will guide you. But you have to show your effort also. You have to also show your effort. Is that clear, everyone? So try to solve it out, because this is a very easy question based on the stop and wait protocol. Now let's come back to the concept. See, actually what happened in case of stop and wait protocol, please try to understand. Means we are trying to analyze the stop and wait protocol. Okay, so here we are trying to analyze the stop and wait protocol. Okay, so see, this is the sender and this is the receiver. Okay, so here we are trying to analyzing stop and wait protocol. Okay, see, suppose the sender has a frame and the sender wish to send a particular frame. So what will happen? Suppose the sender is sending its frame. So definitely once the frame will be received by the receiver, what the receiver will do? It will send back the acknowledgement. So this is the frame, suppose F0 transmitted by the sender, and this is the acknowledgement received by the sender. Okay, yes or no? So this is the frame number F0 sent by the sender, and once the receiver will receive the frame, it will simply revert the acknowledgement frame to just make a confirmation. Okay, so once the acknowledgement frame will be received, please try to understand. Once the sender will receive the acknowledgement frame, definitely it will send a next frame. It will send a next frame, that is the frame number, suppose F1. So my dear friends, suppose this particular frame F1 is lost in between the network. This is representing lost. Okay, suppose this frame F1 is lost in between the network. So what will happen? How much time the sender has to wait for the acknowledgement? It should be limited. Suppose if you are sending any parcel to your friends, so how much time you will wait whether the parcel sent by you has been received by your friends or not. There should be some limitations, because you cannot wait for the infinite period of time. Are you getting my point or not? We cannot wait for the confirmation for the infinite period of time. Are you getting my point or not? There should be a time limitations. There should be a time limitation. So here in the first situation, what we are observing, this is the total time. This is the total time, because this is showing the timeline. This is showing just a timeline. So this is the total time to send a single frame successfully to the receiver. So in the next time, whenever the sender is sending a frame, how many times it has to wait for the acknowledgement? This much time? Yes or no? So if this particular time is known, then if this particular time is known, then according to this, what the sender will do, it will set the timer. Okay, and the time duration of this particular timer will be this means, it basically means within this period of time, if the acknowledgement is received, then everything is going fine. But if the sender does not receive the acknowledgement within this specified time, which is set by the timer, it means what the sender will think, either frame or the acknowledgement has been lost. So if the frame is lost, then what the sender will do, it will simply retransmit the frame. Are you getting my point or not? So what basically happen, whenever the sender transmit a frame, is just start a timer. So after some time, this timer will get timeout. Yes or no? After some time, this timer will get timeout. So here in this point, what will happen? Timeout occur. So before the timeout, if the sender is not receiving the acknowledgement, what it will do? It will retransmit. Just after the timeout, it will retransmit the frame F1. So here retransmission will be done. Retransmit the same frame F1 which has been sent earlier. Yes or no? So here in this situation, this frame F1 is simply transmitted. And since within the timeout, the acknowledgement is not received by the sender, so after the timeout, what the sender will do? The sender will retransmit the frame. So why we are setting up the timer? To just verify whether within this time, whether we are getting the acknowledgement or not. Because this is the maximum time up to which the sender can expect for the acknowledgement. If acknowledgement is not coming, it simply means either the frame or the acknowledgement has been lost. In any of them, in any situations, what the sender will do, it will simply retransmit the same frame. So my dear friends, please try to understand one thing. See, here after the timeout, what the sender is doing, it is retransmitting the frame. It simply means whenever the sender is sending a frame, it gives the copy of the same frame. Yes or no? Suppose if I am a sender, if I am sending a frame, then what I will do, I will keep the copy of same frame. Why? If the losses will happen, I can use the same copy to retransmit the same frame. Are you getting my point or not? to retransmit the same frame, and these things I am writing in the form of points, so please remember this. Okay, so whenever sender send a frame, it keeps copy of same frame. Why the sender basically keep the copy of same frame? Because if loss means either frame or acknowledgement. Loss, whenever we are using a term loss, it simply means either frame or acknowledgement. Okay, because either the frame could be lost or the acknowledgement could be lost. Okay, so because if loss will happen, then sender will use same copy to retransmit the same frame. Are you getting my point or not? So this is the first point that we are identifying in this analysis. The second point is how much time the sender will wait for the acknowledgement. It should be limited, and for that reason the sender set a timer. Okay, so to limit or you can just simply write in a simple words. Okay, how much time sender will wait for acknowledgement frame. It has to be set so that sender could not wait for infinite time. Are you getting my point or not? So it has to be set. Okay, so basically sender, so due to this reason sender set a timer. The sender set a timer. So within this time, if the acknowledgement is receiving, then all things are going fine. Everything is going fine. And if the sender is not receiving the acknowledgement, then the sender will assume either the frame or the acknowledgement has been lost, and just after the timeout, the sender will retransmit the same frame. So these are the two things that we are ultimately analyzing during the stop and wait protocol. So my dear friends, here I am winding up the first topic, that is the stop and wait protocol, because we have already dealt with the concept as well as we have already deal with all the associated numerical asked in the previous year. So from the tomorrow I will start the new topic, that is the sliding window protocol, which is connected with the stop and wait protocol. See, every protocol has some advantage as well as disadvantage. So first of all, we will try to identify what is the drawback with the stop and wait protocol, and then how we can overcome this drawback with the help of like sliding window protocol. Okay, so if you are switching from one protocol to the another protocol, there should be a reason. Yes or no? There should be a reason. Definitely you are identifying something useless inside the first protocol, and that's why you are adopting the another protocol. Is that clear? So in the tomorrow class, first of all, we will look upon the first protocol, that is the stop and wait, and their drawbacks, and then we will try to overcome the overcome the drawback inside the first protocol by introducing the another protocol. Okay, so before leaving this particular session, once again I will tell you from the tomorrow, my dear friends, once again I will tell you from the tomorrow I am going to start the computer network in live app. So from the tomorrow I am starting the computer network subject in live app will with full fledged. Okay, so if you want, you can attend the 3 days demo classes in our YouTube channel, that is the Gate CSIT YouTube channel, and you can just feel the difference. Once you will attend the sessions, you can feel the difference, because since the session will be held in the app parallel with the YouTube, and in the Gate CSIT YouTube channel, definitely there I will take the session in a bilingual language. Okay, means Hindi as well as English. So must attend 3-day demo classes, and if still you haven't decided to make your career through the Gate, just think about it. Because this is the one of the new batch I am going to start from the tomorrow means 9th May, okay, 9th May at the rate 7 p.m. So must attend this session. Okay, feel the difference, and then set up your mind and go ahead and choose your right career through the Gate, because you have a lot of opportunity through the Gate exam. Either understand these things now, or later you will have only a regret, nothing else. If you are not able to understand these things right now, definitely later on you will nothing have apart from the regret. Okay, so just start your journey. So if you want, you can take the demo classes, and if you are satisfied with all these things, then you can go for our live app courses also. Okay, so that's all for this session. We will see you tomorrow at 7 p.m. in CSIT, Gate CSIT YouTube channel. Okay, so bye, take care everyone, Jai Hind.